So we need to talk about absolute value with inequalities. With this example, we've got absolute value of x minus 4. And it says it's greater than or equal to 0. Well, that should be a really easy problem, and you're going to see that anytime you have absolute value of something that says greater than or equal to 0, the answer is going to be all real numbers. And that's because anytime you take the absolute value of any number, it has to be positive. There is no, you can't take the absolute value of negative 55 and still have a negative. Well, the only thing less than 0 would be a negative number. So since this has to be positive, it has to be anything from 0 and above. And we got the equal sign there, so it counts the 0. Now, if the equal sign wasn't there, let's just say for argument's sake the equal sign was not there, and we just had, I erased too much of it, maybe it just looked like this. Well, now we can't just say all real numbers, because now there's the instance to where this is actually going to be 0. Where if this comes out to 0, then that's 0. And so what we'd have to do there is set it up and just say x minus 4 equals 0, and because we want to see what this is. So if we want to add 4 to each side, so when x equals 4, then that's the only place where we don't have a value that works. Everything else works except for positive 4. So that would be all real numbers except for positive 4. And you could write this a couple different ways. You could say, we could use interval notation like this. We could say negative infinity to positive 4. Put our big U there, and then 4 to positive infinity. That's a crappy infinity sign, but there it is. And that works. And we could have also written it as an inequality, which would have been fine just as well. And if we flip the sign around, now you can see I flipped that around, then now it says we want this to be less than or equal to 0. Well, now instead of being all numbers except for 4, like how it was when we didn't have the equal sign, this case, it can only be 4, because the only number that can come out of this that will be less than or equal to 0 would be 0, because you can't have anything less than 0. You can still be equal to 0, and to be equal to 0, then x would equal 4. And that would just be your answer. That's the only thing we have. Now let's take off the equal sign. We don't have an equal sign now. It used to be there, but now it's not. Now it just says the absolute value of x minus 4 is less than 0. Again, like I said, you can't have anything less than 0 when you take the absolute value, so it'd be no solution. And you're going to get the hang of these. They're not that hard to understand, and I'm actually going to share a big sheet that's going to give you a bunch of information about it. Now let's look at our regular types of problems that we're going to see. Now we've got 3 times the absolute value of 4x minus 1 is less than or equal to 9. So since this is less than or equal to 9, first thing we need to do is start simplifying. So we want to divide that 3 off of each side just to get rid of this and get this 4x minus 1 by itself. And I should say minus 1. It looks like a little minus sign, but I fixed it. 9 divided by 3 would equal 3. So we'd have absolute value of 4x minus 1 is less than or equal to 3. Now we do our regular inequality stuff. This is the point where we split it up into 2 different problems. Go ahead and make this a little smaller. This is the point where we would split this up into 2 different problems, and we're still going to do that. So I want to set it up as 4x minus 1 is less than or equal 3. Now the time that we keep our 3 positive towards, whatever's here comes down here, we're going to keep the sign the same. But on the one where we would set it up to negative 3, we're going to go ahead and say 4x minus 1, we get to flip the sign now. And you need to keep in mind that I'm not saying that if the 3 is positive, then we've got a less than or equal to sign. I'm saying we keep whatever sign we have originally. So if that sign is what we have with our positive 3, we're going to bring that sucker down with the positive 3. When we change it to the negative 3, that's when we change our sign. So it doesn't matter which way it is in particular, just whatever we have here comes here, and then we do the opposite over there. And it'd be the same thing if we didn't have the equal sign. If we didn't have the equal sign, then it would come down without the equal sign, and then we flip, and you still wouldn't have the equal sign. So just keep that in mind. But now we can go ahead and solve normally, just like a regular equation. So we're going to add 1 to each side. And we'll have 4x is less than or equal to positive 4. And then we can divide by 4. And we should have x is less than or equal to 1. And then over here on the right side, our other problem, we're going to add 1 to each side. We'll have 4x is greater than or equal to, that's going to make it a negative 2. So we divide by 4. Negative 2 over 4 is going to reduce, and this is going to be negative 1/2. And I know I don't do a very good job of drawing those signs, but you should be able to follow the math at least. I'm going to go ahead and give you one more example here. This is a little bit more involved problem. We have the minus 4 out here, and then we'll have to get rid of the 2 and then work from there. All this stuff just kind of works the same. We'd add the 4 first, get rid of that, and then we'd have 2 times the absolute value of x minus 1 is greater than or equal to, and 2 plus 4 is 6. At this point, now we would divide our 2 just like normal, get rid of that. We have absolute value of x minus 1 is greater than or equal to 3. Now we're at the point where we would switch and make it 2 different problems. Let's go ahead and do that. And we'll have x minus 1 is greater than or equal to 3. Remember, I kept the exact same sign I had here because I brought down my positive 3. And then whenever I do the setup for the negative 3 version, now I can switch my sign around. I just flip it and have negative 3. And now I can do my math. So I'm going to add 1 to each side. X is greater than or equal to positive 4. And then also, I want to add 1 to each side over here. X is less than or equal to, and that's going to be negative 2. Now, something I forgot to go over on the last problem was we got to think about how we can write these. We can definitely just write out 2 different ones, but what we want to look at is we're looking at if this is an and or an or situation. On this one, you've got x is greater than or equal to positive 4. For this problem, you can't have a number be greater than or equal to positive 4 and less than or equal to negative 2. So that would be an or situation where you'd say x is greater than or equal to 4 or x is less than or equal to negative 2. If this would have been a different issue, and just to make sure we don't have any confusion there, I'm going to completely wipe out this problem. So I'm going to write a whole new example. I'm not going to do all the math. I'm just going to show you how you would write a problem or an answer. So let's say we had x is less than or equal to 9, and then we also had x was greater than or equal to negative 6. I just made something up. Well, that's a situation where you can have the same numbers that are less than or equal to 9 and greater than or equal to negative 6. So you've got 2 separate boundaries. So like if we had it on a number line, it's just going to be a rough sketch of a number line, but if we had positive 9 here, we'll say this was negative 6. Well, the values that would be included would just be from the negative 6 to the positive 9. You can't go anything below the negative 6. you can't go anything above the positive 9. So that would be written as a compound inequality, to where you would have had, you write your lowest number first, put the sign, be less than or equal to our x, but then our x is also less than or equal to our positive 9. So that would be written as a compound inequality. You could have also went ahead and said, since we got the equal to's included as well, we'll use brackets and we'll do our interval notation. We'll say 6 to positive 9. If we didn't have our equal signs, whichever one we didn't have an equal sign with, we'll make a parenthesis. So if this didn't have an equal sign with the 9, then it'd be a parenthesis. Now on these ones, the types of problems we're doing, if you have an equal sign on one, you're going to have an equal sign on the other, because the whole point is you flip the sign. You're using the same sign. But just in general inequalities, keep in mind that if you have a negative or an equal sign, that means you're going to use a bracket. And if you don't have an equal sign, you would use parentheses. In this case, we have our equal signs. We would use brackets for interval notation. And then also you could have written as a compound inequality. And like I said, using our number line here, that just means that you use all the numbers between -6 and positive 9. Sorry for the long video, but I wanted to try to go over each different type that you might see. And also, like I said before, I will be posting, so look for that. You should have, by the time you're watching this video, you will already have the sheet that I'm going to post with this.